Hello students, good morning, good evening and good night. Depending on which time you are going to observe this lecture, welcome to the first lecture on hydrocarbon. Hydrocarbon chapter basically includes in your class 11 chemistry syllabus, and in this chapter it is some topics that has been included, that is the different types of hydrocarbons and its preparations and its chemical and physical properties, and also the nomenclature also included, and in some form that is the isomerism and conformations also included. But we will discuss only the physical properties, chemical properties and preparation of the hydrocarbons. Hydrocarbons, if you find that it is a very important aspect, very important things in our day-to-day life that we are using. That is, as for example, it has been used as a fuel because hydrocarbon is a source of energy. Fuels means that we know, that is familiar with this word, that is LPG, CNG or LNG. All are basically used as a fuels in automobiles or our day-to-day cooking purposes, and these are very important things, and they are basically the hydrocarbons. Not only that, hydrocarbon is used in the preparation of the different types of polymers, and it is also used some dyestuffs and chemical intermediates. So importance of hydrocarbons cannot be overemphasized. So that is a very important topic, and hydrocarbon is basically, if you see, that it is being classified on the basis of the carbon-carbon bond. Some hydrocarbons, which is saturated hydrocarbons, which is having the carbon-carbon bond is single bond, there is a single carbon-carbon bond, and also in the carbon-hydrogen there is a bond. And this is the alkenes. There are another type, this is saturated hydrocarbons, another type of hydrocarbons, that is the unsaturated hydrocarbons, where you will find the carbon-carbon double bond or carbon single bond. And another type of hydrocarbon, that is the aromatic hydrocarbons, that is a special type of hydrocarbons. So in this lecture we are going to discuss the preparation of the alkane. So heading of to this lecture is preparation of alkane. Alkane is basically the saturated hydrocarbons, where you will find there is a carbon-carbon single bond and carbon-hydrogen single bond. And when these carbon atoms are joined together and form a open chain of carbon atoms, it will be called as alkanes. And sometimes you will find some product, you will find that there is, instead of open chain, there is a closed or a ring, and this is called the cycloalkanes. The first member of this alkane family is methane, and then there is, depending on the carbon atoms, as the carbon atoms goes on increasing, that family goes on increasing, that you can see, that is methane, ethane, propane, then butane, pentane. In this way, that there is different types of alkane you will find. And alkane is also called the paraffins because it has very little affinity towards the chemical substances like acid, base and chemical reagents. That is, it is called the paraffins. And the general formula of the alkanes is CnH2n plus 2. This is the general formula of the alkanes. First, we will discuss one very important process by which you can able to prepare this alkane, that is from unsaturated hydrocarbons. Unsaturated hydrocarbons. Unsaturated hydrocarbons, that is alkenes or alkynes, are basically unsaturated hydrocarbons. When we do the process of catalytic hydrogenations of these alkenes or alkynes, there will be the formation of the alkenes. The examples is, this is alkene. This is alkene, but it is ethane. And when we hydrogenated it in presence of hydrogen gas, and also you have to use either nickel you can use as a catalyst, or you can use platinum, or you can use palladium, and it will go to produce this alkane. This is ethane. We can produce a ethane. This is the process from the unsaturated hydrocarbons. In the same way, we can produce this hydrocarbon from, this is a propane. And in the same process, we will find that it will have this alkane, that is propane. From the ethyne, from the alkyne, that is this is propyne, and we use this, so we hydrogenated it in presence of the nickels or platinum, palladium. It is going to produce this propane. So what is going to happen when we flow the hydrogen gas through this finely divided nickel, platinum or palladium? What is going to happen on the surface? They will absorb the hydrogen, and the bond of the hydrogen molecule has been broken, and with this process they will the hydrogen has been incorporated in this unsaturated hydrocarbons, and accordingly it will going to produce this ethane. And here one thing that we need to understand, you need the information, that is, when we use this platinum or palladium, it can be hydrogenated at room temperature. Whereas in case of nickel, you have to have some pressure and temperature is required for this reaction. Pressure and temperature is required in case of nickel, but at room temperature you can able to have this hydrogenation in case of platinum and palladium. So this is from the hydrocarbons. Now second process that is going to be, that is from the alkyl halides. Alkyl halide you can able to produce, except fluoride. From the fluoride you cannot able to produce this hydrocarbons. In this way, there is also a reduction is going on. Alkyl halide is reduced in presence of your acid and zinc. With the acid and zinc, there is a preparation of the hydrogen, and this hydrogen is going to reduce this alkyl halide. As for example, this is chloromethane. When it is in presence of zinc and acid, hydrochloric acid, dilute hydrochloric acid or take, and it will going to produce the methane and HCl. In the same way that we can, this is chloromethane and we can have chloroethane. In presence of zinc and acid, it will going to produce the ethane and HCl. From the alkyl halides, you can able to produce this. Another reaction, very important reaction, that is the Wurtz reactions. Wurtz reaction. In this reaction, that what we find that is very helpful reaction, that when we want to have the higher alkanes, from the methane we want to produce the ethane, or from the ethane we want to produce the butane. At that time, this reaction is very much important. This reaction is carried out in presence of the dry ethereal solution. Dry ethereal means that will be no moisture. Dry ethereal solutions in presence of the sodium metal, this will going to produce higher alkanes, and these alkanes will be the even number of carbon atoms. As per example, we are taking, that is bromomethane plus sodium, and here 2 bromomethane molecule will be in presence of dry ether. Present of dry ether, it will going to produce the ethane. So this is a very, very important reactions, and from this reaction you can able to produce the higher alkanes. But there is a drawback of this reaction, that we cannot able to produce the unsymmetric alkanes. Means when the alkyl group of this will be different, that type of we're not going to produce, because at that time that you will find that it is the mixed alkane will be produced. As for example, when we are taking this one alkane alkyl halides, this, and other alkyl halide is different, that is the alkyl group of different. At that time, when we use this Wurtz reaction, it will going to produce the mixed product. That is, it will produce R dash R plus it will produce R and this. So here you can see there is a mixed product, a mixture of three type of product that you can find, and because these three products are not able to, you cannot able to separate it by any other means. So it is a complex formation will be there. So Wurtz reaction cannot be used to produce the unsymmetric alkanes. Unsymmetric alkanes means when the alkyl group will be different. So this will not produce. For that, there is another reaction that we have to see, that is the Curie-House reaction. Curie-House reaction. In the Curie-House reaction, that is also a very important reaction, that we have to use the alkyl halides, and one reagent is used, that is called Gilman reagent. Gilman reagent, and it is basically the lithium dialkyl copper. Lithium dialkyl copper. This reaction is this, or 2 CuLi. It is lithium dialkyl copper. When it is react with another suitable alkyl halides, then it is going to produce this alkane. And here you can see, if we use these orders and R is same, at that time we can have the symmetric alkane. If you have the different alkyl group, you can have the unsymmetric alkane. So both this type of alkane can easily be produced by these Corey-House reactions. And other product that you will find, that is the Cu and LiX. So Corey-House reaction is a more versatile reaction than these OH reactions. Then we have discussed from the alkyl halides, then we have discussed the OH reactions, and we have also discussed the Corey-House reaction. Total 4 reactions that we have discussed. And here it is the 5th reaction that is going to discuss. It is Frank-Land reactions. Frank-Land reaction, it is basically same as OH reaction. In the difference is that in the OH reaction, that is you use the sodium, here we will use the zinc. So this reaction is this CH3I, you have to use zinc, I6 and it will going to produce the ethane, and same that you have to use the diethyral solution, and it is going to produce the ethane, and which is ZnI2. So this is the Frank-Land reactions. Now from carboxylic acid we can also prepare the alkane. And how? Let us understand. 6, that is from carboxylic acid. Carboxylic acid. And here also you can see there is a 2 process. Number 1, that is the decarboxylation. Decarboxylation process, that we are going to eliminate the carbon dioxide from the carboxylic acid, and by this way the produced alkane will have the 1 number of carbon atom less than the parent carboxylic acid from which we are prepared these alkanes. As for example, the reaction of this CH3COONA, we have to take the sodium salt of the carboxylic acid. Here we have taken the sodium acetate. This is basically sodium acetate, right? And the sodium acetate, when it is heated in presence of soda lime, that is calcium oxide and NaOH, it is basically 3:1 ratio. NaOH will be 3 times than the CaO. So when we heat it, it is going to produce the alkane, that is methane, and byproduct is Na2CO3. So this process is decarboxylation. Why? Now 1 molecule of CO2 has been expelled out from this, so it is going to produce the methane. So this is a decarboxylation in presence of the, when we heat the sodium salt of the carboxylic acid, here it is sodium acetate, and it is going to produce the methane. Second B position, that is the Kolbe electrolysis process. electrolysis process. Will be electrolysis process. What is going to happen? The salt, aqueous salt of the sodium and potassium, the salt of the carboxylic acid, aqueous solutions of the salt of this potassium or sodium carboxylic acid. When it is electrolyzes, it is going to produce the alkane, and this alkane will be the higher alkanes and it will have the even number of carbon atoms, and we have seen in case of Wurtz reaction. The reaction is this. When it is electrolysis, when it is electrolysis, and we have to use, that is the water to dilute this salt, and it is electrolysis. When it is electrolyzed, so it is going to produce the C2H6 plus H2 plus CO2 and NaOH. The balance equation is these two, and here is these two. So how this reaction proceeds, let us understand. In the electrolysis process, we know there is a two terminals. That is, the one is anode and another is cathode. And anode, basically this alkane is produced. Here what is going to happen? Basically this is the ionic compound, so it has been dissociated. Suppose this is this, CONA is dissociated into the acetate ion. This is acetate ion and Na plus ion. And this is a negative ion, and we will go to the anode. And in the anode, what reaction is going on? Let us see. That is CH3, C. This is, and it will, 2 electron will be given to this anode, and it is become the acetate free radicals. This will become acetate free radicals. So you can see 1 electron has been, 5 electron collected. So here this is also the this is also again methyl. This is the acetate free radical. Acetate free radical. This is acetate free radical, and it is going to produce the methyl So this is acetate free radical. It will produce the methyl free radical. Methyl free radical. And this methyl free radical, and it is there also production of carbon dioxide here. Carbon dioxide will produce here. Okay. And this methyl free radical will be the ethane. And what will be the reaction at the cathode? In the cathode, the electron has been, this electron that is given by this acetate ion. This is acetate ion, right? Acetate ion. This electron will be taken up by H2O, and it will produce the hydrogen free radical and OH minus, and 2H free radical will produce this hydrogen gas and OH minus. and that is at the anode you will find this hydrogen, in the cathode you will find the hydrogen, and the anode you will find the methane is there. This is the electrolysis process. So these are all for today's lecture. In this lecture that we have discussed about several processes by which we can able to produce this alkane. That is, first one we have discussed from the unsaturated hydrocarbons, from the alkenes, alkynes, that we can able to produce it. Second, we have discussed about from the alkyl halides, that is by use of your zinc and acids. Thirdly, we have discussed about the Wurtz reaction by which we can able to produce the higher alkanes, and there is a disadvantage of the Wurtz reaction that we cannot able to produce the unsymmetric alkane, and we have also discussed to substitute these reactions, that is the Corey-House reactions. From the Corey-House reaction that we can able to have both type of alkanes we can able to produce, that is the saturated hydrocarbons and unsaturated hydrocarbons. Then we have discussed about the Franklin reaction. Franklin reaction is just like the Wurtz reactions, only differences is zinc. In case of Franklin reaction we will use zinc, whereas the Wurtz reaction we will use sodium. And then we have discussed about from the reaction method from the carboxylic acid by decarboxylation process and by electrolysis, Kolbe electrolysis process. So that is all for today's lecture, and we will meet in the next lecture. And if you like this lecture, you can share to your friends. Thank you very much for watching, and thank you.